Hello, welcome to another edition of the Kinases. My name is Rich. I'm a certified nursing assistant. Excuse me. What I really want to go over right now is serine threonine kinases and tyrosine kinases because you can't really understand intracellular biology without understanding the kinase enzymes and how autophosphorylation occurs and how these enzymes phosphorylate other enzymes to perform a cascade of reactions. So understanding the basic chemistry of it and is vital. So right here is the serine. This is the serine amino acid, and there you have it, your amino group, the alpha carbon, and the carboxylic acid group right there. So the name makes sense. It's amino and acid. So amino acid, the name kind of makes sense. So anyway, here's the alpha carbon, and off the alpha carbon, we have a methylene group right here, and then off of that, we have an alcohol group right there. Now over here is threonine, and threonine, there is your amino group, the alpha carbon, the carboxylic acid. And the only difference here is that this has a methyl group right here. This has a methyl group, the CH3, the methyl group right there, off this carbon, the first carbon right here is a methyl group. So, and then there is the alcohol group, again, as you see underlined, and that's threonine. Another thing I want to say too is by drawing out the whole amino acid, what's really happening within the cell is they're as residues. So they're look like in, one of the hydrogens will be missing here, and this alcohol group will be missing here. You write it as a residue, and what a residue is you're writing it as a part of a protein or a part of a polypeptide. This is the amino acid drawn out as in free form. If you just had the amino acid by itself and not part of a protein, this is what it would look like. If you have it part of a protein, then it's drawn out a little bit differently because it's going to be missing pieces of its backbone here. So anyway, I drew the whole thing out because I wanted you to see the whole protein, the whole amino acid. Down here is tyrosine, and again there's your amino group, the alpha carbon with the hydrogen coming off of it, your carboxylic acid group. There's a methylene group right there. There's a benzene ring, and then over here is the alcohol group. Now I underlined all the alcohol groups. You can see the segmentation. You can see the segmentation right there. It's all alcohol groups. So what it's going to do, these kinase enzymes, is it's going to pick up an inorganic phosphate group. And it doesn't randomly pick up these inorganic phosphate groups. It goes to a site of origin, which is ATP, which is your body's vital energy source, and it grabs a phosphate group off of there. It just doesn't randomly pick them up in the cytoplasm of the cell. So here is a phosphate group, and the phosphate group, here's the phosphorus atom in the center here, and it's double bonded to the oxygen right there. And then there's a bond of to an alcohol group right there, and then a bond to another alcohol group right there, and then a single bond to the oxygen right there. The oxygen is trying to get two. It's trying to get two. So what it does is it picks up an electron by ionic means. So it picked up an electron from somewhere else, and it changed its net charge to negative right there. So this has a net charge. This oxygen down here has a net charge of negative, as for this one up here has the double bond to the oxygen. So one of the electrons that it picks up is from the covalent bond from the phosphorus atom. So Now here, there's the alcohol group here and the alcohol group here, and what will happen is this alcohol, these two alcohol groups will perform a condensation reaction. So the hydrogen and one oxygen comes down here to water. So it's a condensation reaction right there. This right here is what's called a phosphoester link, because now the oxygen will bind to the form a covalent bond to the phosphorus. So there's a covalent bond between the oxygen and the phosphorus now. Now the tyrosine and the phosphate are attached to one another. And that's what's happening when these kinase enzymes are going around. And the same thing is going to happen with the serine, where there's going to be a condensation reaction, and then the oxygen of this is going to form a phosphoester link or a covalent bond with the oxygen that's on the amino acid. And same thing over here. This is going to perform a condensation reaction, and then the oxygen that is on the amino acid is going to form a phosphoester link or a covalent bond with the phosphorus atom. And that will, it's a condensation reaction, so it'll leave water. What else did I want to say about this? Oh, the reason that this is called a phosphoester link is because if you did this, if you got rid of this portion right here, which I'm going to do, if you got rid of this portion right here, and you change this to a carbon instead of a phosphorus, you would have a carboxylic acid group. So when two reactants come together and form an ester, called esterification, when the oxygen binds to the carbon, we'll call it an ester link. But because these links are so similar, the ester link and the oxygen to the phosphorus link are so similar that instead of calling it an ester link, they'll just call it a phosphoester link because they're so similar to one another. But this one is a phosphorus in the center here. And if you put a carbon there, then it would be an ester link. So you just throw that phospho in there to show you that it's so similar, and it has to do with a phosphorus instead of carbon. But that's getting rid of the rest of the phosphorus group, though, because a carbon only wants 4 links. So that is it. Rich, Kinases, see you later.